Day 3, we'll take a look at arithmetic and geometric sequences. Warm-up. Consider the function f given by f of n equals 3n minus 7. This function takes an input, the n, and it multiplies it by 3 for that 3n, and then subtracts the 7. Can you mentally evaluate the following? So the first one is f of 10. What that means is you're plugging in a 10 for n, so here's what you should be thinking in your head. What is 3 times 10? And then you'll subtract the 7. So we can say f of 10 equals 30 minus 7, or 23. So the input is 10, the output is 23. How about this one, f of 10 minus 1? Well, from the previous problem, we know that f of 10 is 23. So this means 23 minus 1, which is 22. The next one is f of 10 minus 1. Notice that 10 minus 1 is in parentheses, so you have to do that first. So this does mean f of 9, which is 3 times 9 minus 7, which is 20. So f of 9 equals 20. And the last one is two separate problems. You'll do f of 5, which is 3 times 5 minus 7. And then you'll do f of 4, which is 3 times 4 minus 7. So for the first one, we'll get 15 minus 7, which is 8. For the second one, we'll get 3 times 4, which is 12. 12 minus 7, which is 5. And so the final answer will be 3. So there's a review of function notation. Okay, so first task, sequences. Here are the values of the first 5 terms of 3 sequences. For each sequence, can you describe a way to produce a term from the previous term? Okay, so for sequence A right here, it looks like we're, and there's a comma missing, we're adding 10 each time. Okay, so that one for sequence A, add 10 to the previous term. For B, it can't be multiplying because you have that 0 there, and 0 times anything is 0. So again, we have to figure out what are we adding or subtracting every time. So here we're adding 5, then we're adding 10, then 15, then 20. So we can say that we're adding like 5 more than the previous term. So start by add 5, then 5 more each time. And then C, if we look at like this adding thing, I don't think adding works, but we can try it. So this is adding 1, adding 2, adding 2, adding 10. So it doesn't look like there's a pattern with adding. Let's try multiplying. This would be times 2. This would be times 2. This would be times 1.5. So it doesn't look like, this one looks like a neither arithmetic or geometric. Okay, so it says, if the patterns you described continued, which sequence has the greatest value for the 10th term? Okay, so how many terms do we have listed? We have 5 terms. Okay, so I guess we could just keep going out. So we have 1, 2, 3, 4, 5. So we have 80, 90, 100, 110, 120. So we need 5 more terms. Okay, and for the next one, we would have, so it'd be plus 25 for the next one. So 75. And then plus 30, so 105, plus 35, so 140. Okay, we can already see that B is going to have the bigger value, and I'm not sure about C because we don't really see the I don't really see the pattern, at least for C. Which of these could be geometric sequences? Explain how you know. So I don't think, unless we change some of the numbers, that any of these could be geometric sequences because you're not multiplying by the same term every time. To check, you can take any number, divide by the one before. So like that first one, we could take the 70 divided by 60, and that is about 1.16 repeating. 60 divided by 50, do we get the same ratio? We don't, it's 1.2. So I don't think any of these could be geometric unless we change some numbers in C, right? So you could make C geometric if this was an 8. And then 16. So if you change this one number to an 8, then C could be geometric because you would be multiplying by 2 every time. So just review of the sequences, and we've looked at these in class for the last 2 days. We've played Book It, we've looked at arithmetic versus geometric. So arithmetic is when you add or subtract the same number, I'll put hashtag, but number, each time to find the next term. Geometric is when you multiply or divide. By the same number to find the next term. So each time to find the next term. I'll just put to find the next term. Okay, Elena says it's not possible to have a sequence of numbers that is both arithmetic and geometric. Do you agree with Elena? Can you explain your reasoning? All right, so in class we'll think about, can you think of a sequence that is arithmetic and geometric? And I guess you could argue something like this, right? If you had just zeros, is just what I'm thinking offhand, this could be arithmetic. We're adding 0 every time. And it could be geometric because you're multiplying. And you could multiply by anything. Anything times 0 is 0. So you could multiply by even like 2 every time. And it could be geometric. So I guess I would disagree with Elena, because if you have a list of zeros, you could make it arithmetic or geometric. Number 5, Jada and I are trying to decide which type of sequence this could be. Jada says, I think this sequence is geometric because in the value column, each row is 3 times the previous row. Typo. Maya says, I don't think it's geometric. I graphed it and it doesn't look geometric. Do you agree with Jada or Maya? Explain your reasoning. Okay, so let's actually graph this. So if you pull up like Desmos, a graphing calculator, we can actually make a graph here. So if you do the plus, make a table with x and y, and we have 1, 2, and 5, 2, 6, and 18. Let's take a look at this. I'm going to kind of pull this down so we can see. Let's zoom out a little bit. Ooh, does this look like it could be? It doesn't look geometric. Geometric looks more exponential. So I guess I would agree with Maya. It does look like it's arithmetic, right? Is there like a slope there? Let's go back to our notes here. And I guess I would just look at this and like fill out the terms in the table. So let's cross off the 5 and the 18. Let's just go up by 1 every time. I think it's easier to go up by 1 for the term number. Okay, so Jada says each row is 3 times the previous row. Okay, so if that was true, then we'd have 2 times 3 is 6. 6 times 3 is 18. Okay, so you can see where Jada got that 18 from, but really, like, you have to look at that term number, and then 18 times 3, I don't even know what that is. We'll type that in. That would have to be 54. And so the fifth term, if it was multiplied by 3 every time, this would have to be 162. If we graph that, that would look more geometric. So I'll show you what that looks like. If it's geometric, we'll change our table here. Can we insert another table? Yeah, we can. Okay, so this one will be red. So 1, 2, 3, 4, 5, and multiply by 3 every time. 2, 6, 18, 54, 162. So here, if we zoom out, oh, you can't really see it very well. Oh yeah, you can kind of see that dot. That one is more geometric. It increases really rapidly. Let's look here though at, is it linear? Because if it's linear, let's change these values. So if it was linear, we would be adding like 4 every time. It looks like 2 plus 4 is 6, so this would be 10, 14, 18. So yeah, this looks linear. So this is actually linear, which would make my correct. Okay, so my is correct. It's linear because we're adding 3 every time. Okay, so daily practice, we'll take a look at, is it arithmetic versus geometric? How can you tell? And then there is this term here, so I wonder, okay, so it says choose a common growth or a common ratio to find the next three terms. So a growth factor, a common ratio is what you multiply by to find the next term. A different growth factor, a common rate, I'm getting a typo here. All right. Okay, so for geometric, it's what you multiply by. For arithmetic, it's what you add or subtract by. Do you need to know anything else? Okay, so if you're adding, if it's arithmetic and you're adding, it's called a common difference. So we'll do this one right here. So this first one, -3, -2, -1, 0, 1, this is arithmetic. And if it's arithmetic, it's called a common difference. If it's geometric, it's called a common ratio. A ratio is what you multiply by, or you can call it rate of change. So here it's the common difference is we're adding 1. Okay, so the main idea, and I didn't have a summary spot, so I'm going to put a summary here. If it's geometric, oops, you have a common ratio. This is what you multiply by. I guess there was a spot I could have put this the notes right here. Arithmetic versus geometric, right here. All right, so here, this number that you add or subtract, or here, let's go to geometric. If it's geometric, what you multiply or divide by to find the next term, that's called a common ratio. I should have put it right here, common ratio. And if it's arithmetic, with the number that you add or subtract by every time, that's called a common difference. Okay, so now I think you have all the information that you need to know then to complete the assignment, which is on pages 9 and 10.